Have you ever wondered what makes your favorite apps feel so incredibly fast and responsive? It's not always about having the most powerful hardware. A lot of the time, the real magic is, well, it's invisible. It's happening millions of times a second. It's less about raw strength and a lot more about solving a really simple kind of elegant puzzle. So let's take a look at that puzzle together.
Okay, so I want you to imagine you're a chef, right? In the middle of a crazy busy dinner service. You've got dozens of ingredients you need for some complex meal. You're chopping, you're mixing, sautéing, and everything has to happen in a perfect sequence right now. But of course, there's a catch. Your workbench, the space right in front of you, is tiny. Like you only have enough space for a few bowls. Meanwhile, you've got this massive pantry, but it's all the way down a long hall. And every single trip to that pantry is slow. It takes you away from the actual cooking. So the real puzzle is, what ingredients do you keep on your tiny, super fast workbench, and which ones do you leave in the huge but really slow pantry? And believe it or not, this kitchen nightmare, it's the exact same logistical puzzle that your computer's processor is solving millions upon millions of times every second, just to run your software efficiently. So in our little computing kitchen, the chef is the processor. That's the part doing all the real work. And that tiny workbench and that giant pantry, yeah, they have direct parallels inside your computer too. That tiny workbench, that's a set of memory locations called CPU registers. They are incredibly small, but unbelievably fast. This is where the processor does its actual work, adding numbers, comparing data, all that good stuff. The pantry, on the other hand, that's your computer's main memory, or what we call RAM. It's huge. It can store pretty much everything your program needs, but it's so much slower. And the speed difference is staggering. We're talking orders of magnitude faster for the processor. That's why every trip to main memory is just like that long, slow walk down the hall. And that, right there, is why this whole thing matters so much. The snappiness of an application, how smooth a game feels, it all comes down to the art of keeping the most necessary data, the right ingredients, in those super fast registers at exactly the right moment. If you manage it badly, you're just making constant, slow trips to memory, and you end up with a sluggish program. The part of the software that manages all this is called the compiler, and it's constantly making two crucial decisions to keep things running nice and smooth. The first decision is called register allocation. You can think of this as the what. The compiler looks at all the variables, all the little pieces of data your program is working with, and it has to decide which ones are important enough to earn a spot on that limited, high-speed workbench at any given moment. It's pretty much the chef deciding, okay, right now I need the onions, the garlic, and the carrots. Everything else can stay in the pantry. Okay, so the second decision is register assignment. This is the where. Once the compiler figures out which variables get a spot, it then has to decide which specific spot, which specific register each one is going to go into. It's the chef saying, all right, onions go in this bowl, garlic goes in that one. It's really important to see these as two distinct but totally related problems that need to be solved. So how in the world does a compiler solve this incredibly complex logistical puzzle? I mean, trying to just brute force the solution would be wildly inefficient. So instead, computer scientists came up with a much more elegant and honestly, surprisingly visual approach. It's called graph coloring. Think of it like this. Step 1, imagine every single variable your program needs is a person at a party. Step 2, now, if two variables are needed at the exact same time, you draw a line connecting those two people. This line means they interfere with each other, they can't use the same register. Step 3, the registers themselves, those are the tables at the party, and each table gets a unique color. And finally, step 4, the goal, assign a color, a table, to every single person with one simple rule. No two people connected by a line can have the same color. And hey, this isn't just some clever metaphor I came up with. A really foundational textbook on the subject puts it perfectly. Graph coloring is a simple, systematic technique for allocating registers. It turns a complex resource problem into a beautiful visual puzzle. Now, this system works beautifully most of the time. But, just like in our kitchen, sometimes there are just too many ingredients you need all at once. And that tiny workbench, it simply overflows. So what happens in our graph coloring analogy if you need, say, 5 colors, but you only have 4 tables? You just can't seat everyone according to the rules. What do? This is where a concept called spilling comes in. Spilling is basically the compiler's safety valve.
When there just aren't enough registers, not enough colors for the graph, the compiler strategically picks a variable and spills it. That just means it writes that variable's value out to the slow main memory, back to our pantry, to free up its register for a more critical variable. It's not a failure, it's just a necessary trade-off. It's like the chef quickly putting the salt shaker back in the pantry to make room for a hot pan. So the crucial thing to get here is that this whole process is a really delicate balancing act. It's this constant dance between speed and space, and it's all managed by some really clever and wonderfully elegant ideas.
So ultimately, that feeling you get from fast, responsive software, it isn't just born from faster processors or more memory. It's so often the result of this invisible art, the millions of these tiny workbench puzzles being solved behind the scenes by elegant algorithms like graph coloring. It's all about being tidy and efficient with the resources you actually have.
It's just a beautiful reminder that even inside our most complex and powerful technology, you can often find solutions and ideas that are as simple, as intuitive, and as human as just figuring out how to color a map or how to seat guests at a party.